Thank you for joining this session on Fabricate with DBT. Before we proceed, a little bit introduction about myself. I am Nandan Hegde. I work as a data architect at Accenture for the Avanade organization. I have been a Microsoft Data MVP since past 2 years. I'm a C# Corner MVP. I'm a Microsoft Data Community Champion and a Microsoft Fabric super user. I enjoy writing blogs, and you can see my blogs at my site. You all can reach out to me either via my Twitter profile or via my LinkedIn profile. Now, let's move to the main topic. That is Microsoft Fabric. Now, what is Microsoft Fabric? So Microsoft Fabric is basically a SaaS tool. SaaS meaning software as a service tool provided by Microsoft and an all-in-one analytics solution for enterprises that covers everything from data movement to data science, real-time analytics, and business intelligence. It means it's a one-stop shop for everything in our day-to-day data world. So one can state that Microsoft Fabric is an end-to-end analytics and a data platform designed for enterprises that require a unified solution. When I say unified solution, meaning cover everything from data movement in form of data factory, data ingestion or storage in form of data warehouse, data science, real-time analytics, and business intelligence. And everything is covered under one concept of one lake. Now, those familiar with Azure Synapse in Azure PaaS, meaning platform as a service, can consider Microsoft Fabric as somewhat a SaaS equivalent of the same. So one can state that Microsoft Fabric is a SaaS compose tool of Azure Synapse with much more advanced features and functionalities that is present. So in this session, we would be covering two basic concepts of Microsoft Fabric and one major concept which would be used in aspect of a tool called DBT. So let's move over to the first aspect, that is one lake. Now, as I said, Microsoft Fabric considers everything under one foundation of one lake. So what is one lake? So one can consider that, sorry, can everyone go on mute if possible? Okay. So one can consider that one lake is a logical storage of data that provides one-way access to all the Fabric data across your tenant. Meaning there is a 1:1 correlationship between one lake and a tenant. Meaning there can be only one lake associated to one tenant. Hence, it's a logical storage of data that provides one way to access all the Fabric data across your tenant. When we say all the Fabric data, it includes all data items from the Fabric, which includes files or tables in the data storage layers like Lakehouse, Warehouse, Event House. Also, Power BI, semantic models, data flows, etc. So all the data that is present within the Fabric is logically stored in one lake. So one lake is not a physical storage in itself, it's just a logical storage. And in the back end, one lake physically stores the data in the Azure Data Lake Storage Gen 2, which is a PaaS component of Microsoft. Eventually, I'll show how the one lake appears in the Fabric version. But for now, let's go across the basic aspects. Moving to the next aspect, that is lakehouse. As the name suggests, it's a lake that houses all your data if you split it on the terminology basis. So it's like an object that stores the data. Now, data stored in the lakehouse can be in any format. It can be a structured data in the form of tables, meaning having rows and columnar data format. It can be semi-structured data in the form of JSON, XML files, or even unstructured data such as PDFs, images, videos, etc. Those familiar in Azure PaaS world can correlate Azure storage account as somewhat equivalent of Lakehouse, wherein in Azure storage account, you could store structured data in the form of Azure tables. You could store semi-structured or unstructured data in something called as Azure blobs, that is binary large objects. So Lakehouse can be considered as SaaS equivalent of Azure Data Lake or Azure Storage Account. Now, one benefit of Lakehouse, unlike Azure Storage Account or Azure Data Lake Storage, is it provides two different development environment versions. Meaning, for data and business analysts, it provides a default semantic Power BI semantic model, which they can directly connect and do their reporting and analytics. Whereas for database developers, it provides something called as a SQL Analytics endpoint. So unlike Azure Blob Storage, wherein one could only do a semantic model, Lakehouse provides an additional aspect of SQL Analytics endpoint, wherein we can query the data in the form of normal SQL queries. It's on this concept that we are building the next aspect, that is DBT. But one aspect is the Lakehouse SQL Analytics endpoint as of today only supports read-only commands. It does not allow to write back. So please remember this major aspect because this would be the major point in a subsequent. Meaning the SQL Analytics endpoint of Lakehouse is a read-only mode. You cannot write back. So now coming to the final and the major aspect on which we would be discussing the next subsequent aspect is the warehouse, or what we call as the Fabric Warehouse. So Microsoft Fabric Warehouse can be considered as a T-SQL software as a service database functionality provided to us by Microsoft. So Fabric Warehouse is a high performance database that most all the complexity of running the database at scale behind the scenes. Meaning it provides us a database like platform wherein we need not govern the scaling and other aspects. It's internally governed by Microsoft in terms of the Fabric capacity that has been associated with the workspace. So those familiar with Azure Synapse Analytics can correlate Azure Synapse serverless version of the Azure Synapse as the PaaS version and Fabric Warehouse as the SaaS version of the Azure Synapse serverless, wherein you can query the data as well on a virtualized basis. But there are certain T-SQL commands that are yet not supported in Fabric Warehouse that are supported in Synapse serverless. And eventually Microsoft is trying to upgrade the functionalities, T-SQL functionalities within the warehouse. Now there is a major reason behind that. Unlike Synapse serverless, in case of Microsoft Fabric, everything is preserved in the form of delta Parquet files. So with Parquet version, there comes some limitations and restrictions with respect to the commands that can be utilized, thereby creating this minor discrepancy with respect to the T-SQL utilities. So now let's see the demo aspect of these three components before we proceed to the major aspect called DBT. So any queries till now? Okay. So let's go across the lakehouse first. So in case of a lakehouse, as I said, lakehouse supports three versions of data: structured data in the form of tables, semi and unstructured data in the form of files. So in this scenario, as of now, I do not have any tables, hence it's not preserving it. I have file in my lakehouse. I can physically load this file into a table within my lakehouse. So one can consider lakehouse as a storage layer for any type of data. So now it is physically loading or creating a table within my lakehouse via the file. So by the time this is happening, I'll show another aspect, that is Fabric Warehouse, or the concept of one lake. Now you can see there is a symbol called one lake data hub. So one lake, there can be only one lake per tenant, and it hosts all the data that is present within the fabric within that tenant. So in my tenant, I have something called as Power BI semantic models. I have a lake house and a warehouse and certain other aspects. So one can consider one lake as the union of all the data that is present within my tenant. And the final aspect is the fabric warehouse. And before the warehouse, now this is the lake house. Lake house, as seen earlier, provides two development environment versions. One is a semantic model that can be leveraged by the Power BI developers or the business and the data analysts. Another is the SQL analytics endpoint, which can be leveraged by the database developers. Then there is warehouse. In case of a warehouse is like a database equivalent in our fabric world. So one can create schemas, tables, everything within the warehouse. As of now, this is a blank warehouse that I have created, and eventually we'll work across populating this warehouse. Now, if you see, I'm able to see a table called test that got generated from the CSV file that got loaded. Now, this was that's present within the file that got physically converted. But in case if we see at the back end, even though in the front end it's a table, at the back end, Fabric preserves the data in the form of Parquet and Delta format. Delta for transactional aspects, transactional logging. So when we said Lakehouse provides us two versions of endpoints, this is the front end, but it also provides us a SQL Analytics endpoint wherein we can query it. So I'm switching over to the SQL Analytics endpoint. In case of SQL Analytics endpoint, I can query the data in the form of SQL queries, thereby allowing any database developers or those familiar with SQL to query the data and analyze the data. So this is how we can query it. Now, in case if I try to insert anything, this would fail because SQL Analytics endpoint is only read-only mode. It does not support data manipulation language. Whereas in case of Fabric Warehouse, it's a database. So you can do DML as well as DDL, anything. So it is this reason that the main tool that the open source tool that we would be using is supported only for Fabric Warehouse and is not supported for Fabric Lakehouse directly, because Fabric Lakehouse SQL Analytics endpoints does not support write functionality. It is a read only aspect. So now coming to the major aspect is DBT. So what is DBT? DBT is an acronym that stands for Data Build Tool. It is an open source software that enables data analysts and engineers to transform and model the data into the data warehouse. When I say into the data warehouse is a logical aspect that I'm speaking of here. One can have a data warehouse with any sink. It can be an Azure SQL database. It can be a SQL server. It can be data fabric. It can be BigQuery, multiple databases. So DBT is an open source tool that helps or enables analytic engineers to transform the data in their warehouses. It can be any warehouse by writing simple select statements and turning these select statements into tables or views within the database. So one can consider that DBT is a transformation workflow, since it converts the SQL query or SQL statements into the corresponding database tables or views. One can state that DBT is a transformation workflow that allows any business analyst and even developers comfortable with SQL to design and implement their own data transformations. So in the traditional data engineering world, it's either the ETL or the ELT process that we usually follow. That is extract, load and transform, or extract, transform and load. So the data build tool does the transformation, that is the T part within the ELT process, and it does not extract or load data. When I say does not extract or load data, does not extract or load the base or the source data, but it is designed to be performant at transforming data that is already present within the warehouse. So one can state that it simplifies the ELT process by focusing on the T, that is the transformation, and it integrates seamlessly with modern cloud-based data platforms. Now, a little bit about DBT history, in case if anyone is interested. That is, DBT tool was originally built by a company called Fishtown Analytics, which was recently, a couple of years back, renamed as DBT Labs. Now DBT Lab not only supports data build tool, but has also some of its own other products. Now, since DBT is an open source tool, DBT has two versions in which one can leverage that. One is the DBT core. So DBT core is an open source Python package run via the command line that helps you to transform, document, and test your data. Meaning, DBT core is a CLI version of the DBT tool, whereas DBT cloud is a web-based UI that allows one to both develop and deploy data pipelines built, and it is built on top of DBT core. So in layman terminology, one can state that DBT core is an PaaS version of DBT, wherein you are responsible for setting up your engine on which you want to execute the package, whereas DBT cloud is a SaaS version of the DBT tool, wherein DBT labs provide you the environment on which you can execute the DBT. So DBT core version is a free open source software, whereas for DBT cloud, you need license since you're executing your jobs on the SaaS platform. Now, before we move to the benefits and other aspects, let's go across certain aspects, some demo aspects. Let me first see are there any queries or not, and then we can move on to the next aspect. Okay. So now, since DBT is and in this demo, we would be covering the DBT CLI version. Since DBT CLI is an IS/PaaS version of DBT, I have to set up my own environment on which I want to execute. So for that, I have created a virtual machine on which I'll be executing the CLI version. So this is the engine on which my DBT would be running on. Now, as I said, DBT is a Python open source package. Hence, I need to install Python. So in this VM, so the minimum requirement is first have Python installed. So as a precursor, I have already installed Python within this server, and this is the version. Now, as per Microsoft, okay, sorry, I skipped up on couple of aspects, correct? Apologize for that. Aspect that I failed to mention was DBT being an open source tool is basically, as I said, it is used to transform the data that is present within the warehouse. And the warehouse can be in any structure. It can be Athena database. It can be Azure Synapse. It can be Databricks, BigQuery. So there are certain trusted adapters which is managed, maintained and managed by the DBT labs themselves, which includes this set of adapters. And the adapters for Microsoft world is Azure Synapse, Databricks, and Microsoft Fabric. And in Microsoft Fabric, it supports connectivity to Fabric Warehouse, as Fabric Warehouse supports DDL as well as DML, unlike Lakehouse, which is only for select aspect. There are some community adapters as well, like DuckDB, MySQL, wherein it's the community adapters. Since this is an open source tool, for every adapter, there is an equivalent GitHub repository wherein anyone among us can contribute for the assessment for the latest functionality. So is the DBT Synapse adapter GitHub repository that was initially created by the community, which is now managed and maintained by DBT Labs themselves. So in this call, in this session, we would be discussing the DBT and the fabric, that is the fabric warehouse connectivity aspect. So we'll be focusing on the fabric warehouse adapter. Now, according to Microsoft, DBT fabric adapter needs a minimum version, Python version of 3.7 or more. Now, since we are connecting to a SQL endpoint, hence the another major requirement is to have open database connectivity, that is the ODBC drive. So these are the two minimum requirements that one must have within within the server on which we need to install the fabric. Now, within my server, as we saw, the minimum requirement was 3.7. I have a version of 3.1, 12.5, which is higher than that. So we can proceed with installing DBT Fabric within this system. So unlike any installation of Python packages, we do a pip install and the package name, that is the DBT Fabric. So by the time DBT Fabric is getting installed, let's take a couple of aspects. DBT Fabric is only a subset. DBT supports multiple adapters, as we saw a couple of minutes earlier, correct? So now here the installation was completed. Now I can execute pip list command to check which all additional packages and dependencies were installed for DBT Fabric to work. Now, if you all can see, these are the different packages that got installed, but there is one package called DBT Core. So DBT Core is the base version on which multiple adapters have been built up. So by default, DBT Core gets installed. But in case if I do pip install just DBT, it would install all different versions or all different adapters within my system, like adapter for Fabric Warehouse, adapter for Azure Synapse, BigQuery, etc. Since we are focused on just the DBT Fabric version, we did a pip install DBT Fabric. Now, unlike any open source tool or any structural aspect, we need to initialize a project similar to how we do git initialize. Similarly, within DBT, there is a command called dbt init. Dbt init is a command for initializing a project repository for your DBT project. So what does this basically do? Since this is my path on which I'm executing this command, let us go to that path. This is the path on which my command prompt has been, the directory associated with the command prompt. Now, when I do a dbt init, it would initialize a project structure familiar for DBT framework, and we will discuss in detail on those aspects. So by the time this is getting executed, okay, it seems there is some network issue on my end. Let me. So now this is initializing the project for my DBT aspect. Now it would ask me for a project name. So DBT demo live. Now which database would you like to use? Since we have installed only DBT Fabric, it is providing me one option of Fabric itself. But in case if I would have done pip install DBT, it would have provided me with multiple options like BigQuery, etc. Since this demo we are focused on Fabric, let's proceed with Microsoft Fabric. That is one. Now, there is one statement called no sample profile found for Fabric. This we'll discuss in subsequent aspect. But what did this do? It went and created a folder within my current repository and it created a project design wherein analysis, macros, models, seeds, snapshot tests, dbt project.yml. Now, what are these terminologies? What are these YML configurations that we are talking about? Let's discuss step by step. First is the model aspect or the profiles.yml. So now for this demo, we need to is it still not clear? Am I audible now? Sorry in case if I lost intermittently. Okay, it seems okay. So now for this demo, I have cloned a repository of Microsoft called Jaffel Shop. So this is my repository under users DBT, and there I have cloned a repository that Microsoft provides. Now first step is there's something called as seeds. What do we mean by seed? Seeds are CSV files that get loaded as tables within the system. What do we mean by that? Now in certain scenarios, a business analyst or a data analyst has certain mapping tables or certain static tables that he or she wants to use within his or her analytics. That's not an enterprise level data that needs to be preserved within the database, but intermittent mapping tables. So for that, rather than being dependent on the data engineer to physically load the data, one can create a CSV file within my GitHub within my DBT initialization project under seeds section. So let's consider this as a CSV file. So now this file would get converted or get loaded as a physical table within my endpoint within the warehouse. But for me to connect to a warehouse, I initially need to connect to the warehouse. Connecting to a destination database, I cannot proceed because DBT is a tool for transforming data within the warehouses. So we have to connect to a destination endpoint. And that is where a concept called profiles.yml comes in. Profiles.yml is basically a configuration file for setting up a connection to your warehouse. So how does a profiles.yml file look like? So when I did DBT init, I got a message that no profiles.yml found for Fabric. But there are other adapters where whenever you do DBT init, it creates a rough skeletal framework of profiles.yml and we just have to input the connection details. But all other details like target, server name, database name, etc., those get auto created. Since this was not created automatically, we had to manually create a profiles.yml file. So let's scan across what profiles.yml file is. It's a config file that helps us identify on which destination do we want to actually do the transformation. So since we are adapter, we need which is Fabric. Then need to provide the server name and the database name associated with the same. Now, as we saw, Microsoft Fabric has a SQL Analytics endpoint that we discussed about. Fabric Warehouse has a SQL Analytics endpoint, which provides us the connection details. So how do we get the server details associated with that? So in case of a warehouse, if you click on the config aspect, it would provide you the connection details. So this acts as the host name for my warehouse. So let me update the host name. Now let me also update the database name. The database name is DBT Live Warehouse that we would be using. So it is DBT Live Warehouse. Now we provided the host name, the database name, which type of adapter we are using. Now, whenever we want to connect to any destination, the first aspect is to mention the authentication aspect. So in this demo, we would be using CLI authentication, but Fabric Warehouse even supports service principal authentication as well. In case if we get time, we'll see the service principal authentication at the end in case if time permits. For now, we would be proceeding with the CLI version. So let me save the profiles.yml. And now let me connect to this database. So first command that we saw was dbt init, that is initializing the project for dbt. Now once the project is initialized, I need to connect to the destination on which I want to execute this. So for that, the first step was creating the profiles.yml file that provides all the configuration details. Since now the configuration file is ready, the next step is to physically connect it. So for that, we have a command called dbt debug. So what dbt debug does is it goes and searches for a profiles.yml file within your current path, or there is another concept wherein within the entire system./dbt. But since here I've explicitly mentioned in my configuration file, it would scan across for a profiles.yml file within the repository, within the current directory. Ideally, it should not take time. It's some network issue on my end and some lower capacity that is creating this issue. So I apologize for that. So dbt debug command scans the profiles.yml file and connects to that destination aspect. First, let me change the directory to that location. So now it's trying to search for the profiles.yml file at using profiles at this directory. The file was found and was validated, and it is as proper aspect, and it got connected to my database. The connection was a successful connection. Now I use CLI authentication. Since CLI uses OAuth token to access the database, In my previous instance, since I had already leveraged Azure CLI authentication, it is using that cache of token to connect automatically. In case if you are using Azure CLI authentication for the first time on this server, a pop-up would come in wherein you will have to provide your username and credentials. Or the best aspect is you can do AZ login in the Azure CLI, when it would allow you to pop up your username and password, your credentials, to create the Azure connectivity. So now we are connected to the database or the destination on which we want to execute our command. And we saw that the Fabric warehouse is an empty warehouse as of now. It does not contain any tables, anything. So now we have achieved first step of connecting to the destination. The next step is the seed file. Seed file or the seed aspect, as I discussed couple of minutes earlier, is to preserve or manage any static or mapping tables or master data that do not change frequently, allowing business analysts and developers to proceed with their analytics without having a major dependencies on the data engineers. So now within this seed folder, you can see that there are three different files, CSV files that are present. I need to physically load this file data within my Fabric warehouse. So for that, there is a command called DBT seed. So post my connectivity, the DBT seed command would go and first of all scan the files within the seeds folder and then physically manifest that data in the form of tables within the warehouse. So it saw there are three seed files and it created three tables called dbo.raw payments, dbo.raw orders, dbo.raw customers, and these are the number of rows that were inserted. Now let's go and verify within the Fabric warehouse itself. We have three tables: raw customers, raw orders, and raw payments, and the similar data and the structure. So now you all might be thinking that does that mean that one has to forcefully add all the files within this seed folder itself? Meaning, is there a hard coding between dbt seed command and seed folder? So to answer to that question, there is another config file called, okay, I have not mentioned, apologies, project.yml. If you see, there is a config file called project.yml. So within the project.yml file, for seeds path, I have mentioned seeds. This is the folder name that I have provided. So dbt seed comes to the project.yml file and checks the value under the seeds path. And whatever folder is mentioned, for that folder, within that folder, it would scan across all the CSV files. So in case if I have another folder with the name and I can update this value to CSV, sorry, the XYZ, and dbt seed command would come and scan across those aspects. So this, a simple command and a simple file got loaded into tables, allowing quick analytics for all our business analyst and data analyst with a basic knowledge of SQL. So project.yml aspect is a config file that contains multiple configuration details, like for every command, what is the corresponding folder that should be followed. Then initially in the definition of DBT, I stated that DBT is a tool that converts SQL statements into tables or views within the destination. So on what basis does a SQL statement get converted into the table or view? It's via the project.yml file. So here what we are stating that by default, anything within the Jaffel shop aspect should be materialized or created as a table within my destination. But anything within the staging folder under models, anything under staging folders should be created as views. So this aspect can even be created not just at a folder level. I can even state at a specific SQL file level wherein this needs to be a table or a view. So that is the flexibility that this config files provide us of ensuring that we can convert the corresponding SQL statements into either a table or a view. So that was with respect to the project.yml file. So now we covered first step, that is what are the two major config files that are needed, the project.yml and the profiles.yml. And then we covered the dbt seed command. Now let's come to the major aspect of the major transformations that we really like to do. So based on the project.yml, within the model folder, I'll be having all my SQL statements. So here I can write any SQL statements. So this is a normal SQL statement wherein we are using our select statements, we are creating CTs and normal group by aspects. Now these simple SQL statement commands would get converted within either table or view within the database by a command called dbt run. So what dbt run does is it comes and, as I said, first scans the project.yml file. Within project.yml file, it got the path where it needs to scan. It is within the models folder. Then it creates something called as a directed acyclic graph or a DAG in the backend. Now, what do you mean by directed acyclic graph? Basically, we have multiple SQL statements, correct? Imagine that there is a dependency of one SQL on another. So there needs to be a fixed order in which an execution needs to happen, correct? So for that, we need not, unlike data engineering tools like SSIS, Azure Data Factory, Airflow, wherein we have to physically create the data flow for the sequence in which the execution needs to happen. DBT in itself creates a graph, creating a connectivity or lineage of the SQL files amongst one another, and then initially creates the parent objects and then creates the dependent ones, thereby ensuring that everything flows in the necessary order itself. So at the backend, dbt run scans across the project.yml file, searches for the folder in which it needs to search for the SQL files, then creates a directed acyclic graph, and we'll see in next couple of minutes on how the graph looks like, and then executes them in that sequence. Now you can see here, the views got created and then the corresponding tables got created and how much time it took for them to be created. Now let's go and check the warehouse. So earlier there were only 3 tables. Now 2 additional tables got created, customers and orders, and the corresponding views got created. Now in case if I go and see the customers, data is physically present based on the select logic that is created. Now the dbt run command scans across the entire model repository. But in case if there is a need to run a specific model, one can execute DBT run and provide the specific SQL file name for specific execution of, sorry, for the execution of that specific model. But remember, let's say that the orders SQL query is dependent on customer, depending on whether we want to pre-execute all the dependencies or directly execute that. There are different parameters that you need to provide within the dbt run command. So dbt run is a basic command, but on top of that there are multiple parameters that one can pass for customized execution. Now when I said dbt creates an acyclic graph, there is a command that we can execute to generate that ourselves called dbt docs generate. So this generates the directed acyclic graph. It's building the catalog, and that catalog is written in the form of a JSON file within my current directory, in the target directory, current directory in the target section. Now dbt docs serve would host this onto a local website wherein I can go across all the structural aspects or the documentation aspects. So this creates a lineage graph stating that initially these are the raw tables, the base data, the seed files. The stage order, sorry, the customer is dependent on stage payment, stage order, and stage customers. So this won't get executed until these three are completed. So this is internally created by DBT. Now I can check the flow across those aspects, allowing one to analyze the end-to-end lineage of their project for quicker analysis. I can even go across certain documentations. So let's take an example here. And how does it get created? We'll discuss in next couple of minutes. So the customer table, these are the columns. This is the data type. These are the descriptions. It is referenced by this set of aspects. There are certain unit tests available. What is the code behind that? So it provides us the source code. The source code is in the form of something called as Jinja formatting. It's not pure SQL, but it gets compiled into a SQL format, which is the corresponding SQL format. So DBT in itself is creating a data dictionary for the organizational aspects. And we need not explicitly take a look across those aspects. So now we know something called as DBT. Okay, sorry, my command. Sorry for that. So I'm changing the repository. I need to connect to this. So by the time this is getting executed, let's quickly go across. We saw what are seed files. We saw what are models. Models are basically SQL files that contains the transformation logic, basically in the form of select statements. We saw profiles.yml file. Now, the benefits. What benefits does DBT bring in? Models. Writing a simple SQL query and a simple command called dbt run is taking care of all the executions. There is no dependency on data engineers to create a data flow and having that dependencies. A simple SQL statement and a simple command is enabling the analytical engineers and business analysts with a simple knowledge of SQL to do their own transformations. Documentation. As we saw, it auto-generates documentation for clarity on the data processes. It creates a DAG for lineage analysis. Now, DBT snapshot is another command which I won't be covering in this session. But what it does is DBT run in case if you're materializing it as a table, it drops and recreates it from the scratch. There is no history maintained. But in case if you want to preserve SCD type 1, type 2, it's the snapshot command which can be leveraged so that it manages everything in the form of historical transactions. Now there is something called as DBT test. Let me execute DBT test. What it does is it executes all the test cases that have been stated within the YML files, meaning whether the customer ID is not null, it needs to be unique. It needs to have values within this specific aspect itself. So one can have automated unit test cases written. And majorly, it compiles models into SQLs and runs them directly on data warehouses like Snowflake, BigQuery, Redshift, Fabric Warehouse, or any adapters. And it is developer centric with version control abilities since we need a repository on which we are initializing the project. So DBT test ensures that all the test cases are either successful or failure. In case of failures, it won't proceed ahead for that corresponding execution. So since there is 2 minutes, I like to, is there, okay, I see a couple of questions. Is there a limitation on the SQL commands used? Now, the limitation of the SQL command is with respect to the destination aspect. What I mean by that is DBT is just a compiler tool, correct? That compilation is actually happening on the destination on which we are actually connecting. So since we have connected to Fabric Warehouse, till couple of weeks back, Fabric Warehouse could not support truncate command, or Fabric Warehouse as of today does not support couple of commands like some scalar functions, etc. So in that case, DBT Fabric run would fail since your destination itself does not support the SQL commands. So in short, whatever SQL commands are supported by the warehouse that is being leveraged as the destination, those SQL statements would run via DBT. Others would fail in simple aspects. So team, any queries? Okay. Now, there was something called as schema.yml file. So we executed DBT test, but where exactly had we identified the unit test cases? It's the schema.yml file within the models. So here, or in the DAG that we saw, there were a couple of documentations with respect to what is the column name, what is its description, etc. So it's this YML file that acts as the source for generating the DBT docs. Here we provide the descriptions and the test cases. So here a simple statement like unique and not null ensures that the DBT test command after materialization of this table checks whether this column values are unique. It's like select distinct from customer ID with select customer ID count, not null, whether there is any null statement or not. So it physically compiles certain SQL queries at the backend and executes them on the destination itself. So all in all, to summarize, DBT enables a business analyst and a data analyst who has a basic knowledge of SQL to do all the data transformations and job executions without having to worry about additional tools like Airflow, etc. It enables one to write automated unit test cases for data quality validations without having to add any custom logic or custom codes. DBT handles in itself. It creates a data dictionary or data catalog for the users and developers to understand. So as of today, Microsoft supports Microsoft Fabric Warehouse. So thank you, team. In case of any queries, you all can reach out to me either on Twitter or LinkedIn, and these are my profiles. Thank you for being part of this session.